want to start out with a few well-known verses from the book of Hebrews. Now, faith is the substance of things hoped for, the evidence of things not seen. Through faith, we understand that the worlds were framed by the word of God, so that things which are seen were not made of things which do appear. It's interesting. Faith here is the evidence of things not seen. Now, I don't see these things, but I believe them. I'm even fairly sure about these things. But the question is, can I prove these things that I believe in but cannot see? Can I prove them? Nah, I don't really think that I can. But my thought is, so what? So what? I mean, have you ever thought really about how many things you can know and are adamant about, or even know for sure, but you really can't prove them? I want to read you a quote from somebody here, from a man named Stanley Fish. And this is from a magazine called Harper's. Very popular, very old magazine in America, goes back to the 1800s, and it's an exceedingly left-wing publication. I've been reading it for 30 years. It's so well done, and every now and then they infuriate me, but I keep getting it because I just like things that are very well done, whether I agree or not. I don't know if you ever heard of America, the ultra-right political commentator Rush Limbaugh. I listen to Rush all the time. I mean, my friends can't stand it because they know my politics. I'm pretty liberal in my politics, but I listen to Rush, but he's good at what he does. And Harper's is good at what it does, and so I get that. But I want you to listen to this quote from Stanley Fish. He's some professor at an Ivy League college in the East Coast, and he's probably a Marxist, because probably the only Marxists left in America are college professors and the Ivy League colleges. But listen to what this man is saying here. Quote, "In order to assert something and mean it without qualification, I, of course, have to believe that it is true. But I don't have to believe that I could demonstrate its truth to all rational persons. The claim that something is universal and the acknowledgement that I couldn't necessarily prove it are logically independent of each other. The second does not undermine the first." So in other words, he says, I could believe in something, I could be absolutely certain of it, but it doesn't mean that I could prove it to rational people. So in other words, he's saying he believes in certain things that he just can't necessarily prove. You know, I believe that the sun is going to rise tomorrow. I mean, I could say pretty dogmatically that I know the sun will rise tomorrow. But what proof? I mean, what real hardcore proof can I present? All I really have are my past experiences of it rising every morning and some knowledge of the law of gravity and how the law of gravity works. But just because something happens with unceasing regularity in the past doesn't mean it's going to happen automatically in the future. The past, what goes on in the past, is no guarantee of what happens in the future. There's a story of Russell's chicken. This is Russell as in Bertrand Russell, the British philosopher. And every morning the farmer would come out and feed the chicken. So every morning the chicken would, wait with the mouth open to get fed. And morning after morning, the farmer came out to feed the chicken. And then one morning the farmer comes out, instead of feeding the chicken, he chops the chicken's head off. Now the chicken, for whatever amount of logic, had a good enough reason to expect from the past that this would continue to happen. Also, couldn't some unknown factor within the law of gravity cause the sun not to rise? And if you believe in God, that God created all this, and Scripture says that God sustains all this, couldn't, if God wanted tomorrow, to not have the sun rise tomorrow? And meanwhile, I'm aware of no inherent logical contradiction in asserting that the sun won't rise. Thus, do I know the sun will rise, or do I just believe that the sun will rise? Then there's an idea of what they call valid justification. The idea that you could have a valid reason for believing something, even if it's not true. I mean, an awful lot of people from an awful lot of history have had an awful lot of very, very, very good reasons for believing in things that were not true. Say you grew up 500 years ago, and you grew up and you spent your life at the bottom of an equatorial rainforest. That person, I think, would have very good reasons, valid justification, for believing that water could never be made so hard that you could walk across it. Would that person not? If you told this person he never saw it, nobody he ever knew ever saw it for generations, that water could be made so hard that you could actually walk across it and stomp it and jump up and down and stand on it. Person would have very, very good reasons for believing in something that is absolutely not true. Or suppose you were born in, some village in the corner of Pakistan somewhere. And from the time you were a tiny child, you were taught about the glory of jihad, and that the glory of being a martyr for Allah, and that if you died on a jihad, you'd go off to heaven, in the arms of 72 black-eyed virgins. Suppose that's all you were ever taught, and everybody around you believed it. And it was, you read it everywhere. Again, would he not have a valid justification for believing in something that was wrong? So I guess this leads to the question, if people could have a valid justification for believing in things that's wrong, where does that leave us? Where does that leave us who want to believe in what is right and what is true? Is there anything that we could know absolutely for sure, but not only know it, but have powerful proofs for our beliefs? Well, what about mathematics? What about something like math? Many philosophers in the 20th century were mathematicians, or they had a mathematical background. And the idea was that you could find utter certainty there with mathematics. Things like 2 + 2 = 4. Things like that the angles of a triangle equal 180 degrees. Or even strange things that never to this day don't make a lick of sense to me. That, how you can multiply negative numbers and get a positive. To this day, I just can't wrap my mind around it. I mean, you could take a -3 and you could multiply it by a -5 and get a +15. And yet you do. All we know is that -3 times -5 = 15, and 2 + 2 = 4. I mean, these are rock-solid truths that exist apart from the contingencies of human subjectivity. Right? It doesn't matter whether a mathematician eats pork and beans for breakfast or has a doppio latte from Starbucks. 2 plus 2 is going to equal 4. It doesn't matter whether you believe God created math or whether we created it ourselves. These are absolute, undeniable truths. Anyway, my point is that these mathematical truths are certain. In a world where we really can't be dogmatic, we really have no proof that the sun will rise tomorrow, we can certainly prove the great truths of math. Religion is based on faith, something that you really can't prove, but math is based on pure logic and pure proof, right? Well, it's not quite that way. It seems like it turns out that that's not quite the way things really are. Math isn't as provable and as certain as I once thought. And I find that realization utterly, utterly astounding and full of implications for somebody like myself, a person who's called to live by faith, a person who's really called to believe in things that I admit I cannot prove. There's a story that tells about a mathematician who goes to the restaurant. He eats and he gets his bill. And he looks up the bill and he says, well, the arithmetic looks okay, but I fear that the axioms upon which it is built might not be as solid as one would hope. Now, the axioms might not be so solid. Isn't that the whole point of axioms, to be solid? After all, math starts out with axioms, these fundamental teachings on which everything else is built. If you remember something about high school geometry, remember the definition of an axiom? Remember what they told us in geometry, what axioms were? Let me read you a definition from a dictionary. Axioms are self-evident principle, a self-evident principle, or one that is accepted as true without proof as the basis for an argument. Without proof. So in other words, you have to build your entire system of math on axioms, on things that you have to accept without proof. Imagine building a building on a foundation that you can't prove is firm. We're going to build this building. Maybe the foundation of it is firm or not. Are you going to want to build a 30-story building on top of a foundation? Because remember, the axioms are the foundation. You're at the bottom. Everything is built on those. Everything that comes after is built on those. But you can't prove those. Come on. So ultimately, you have to take math and this foundation of math on faith. I can walk into a building, as I said, and I assume that the foundation is solid. But it is certainly a faith thing when you walk into these buildings. But on math? And see, the problems get even a little more difficult with numbers, with math. First of all, do mathematical truths even exist? What does it mean to say they exist? Do numbers even exist? What is a 2? What is a 2 or a 4? Have you seen a 2 lately? What does pure 2 look like? What size is it? What color is it? Does it have body? Does it have extension? Does it have weight? Does it have mass? Or what about a 10? What is a 10? A real one. Is it larger in body and size than math than a 2? You could think of 2 dogs, 10 fish, whatever. But can you just think of the concept of 10? But just because you can even think of a concept, does it give it a reality? I can think of a red-haired unicorn that has the words, I don't know if it means anything to you, the New England Patriots, which is an American football team. I can think of a red-haired unicorn with the words New England Patriots branded on its side. But does that make it real? Does that give it any kind of reality? Okay, now 2 and 10. That's one thing. That's relatively easy. That's relatively easy, though I still can't really in my own mind, a pure 2, a pure 10. But what about a -6 or a -12? What kind of existence do they have? Is a -6, is it a real thing? Does it exist? If it is, where does it exist? Does it exist in some Platonic realm of the forms? And so on. What kind of reality does it have? Or is it just a figment of human imagination like Moby Dick or Captain Kirk in the Starship Enterprise? Or what do you do about this? This is always something that I find rather strange too, this concept of irrational numbers. When you think of numbers, you think of just pure rational thinking, rational thought. But you've got irrational numbers. You got the famous square root of 2, which comes out to 1.4123 and on forever. It goes on forever. Supposedly, I guess they don't know really. I guess, you could keep going and maybe some point, 10 billion digits to the right of the decimal point, it might stop. I don't know. Does that exist? Is that real? Or what about any one of the supposed infinite irrational numbers between 0 and 1? They say between 0 and 1, there's an infinite number of irrational numbers. Are these things just figments of the human imagination, or are they real? There has been a massive philosophical debate for a long time, for centuries now, among mathematicians over numbers and sets. Are they really out there? Are they really out there? Do they exist as something real? Or are they purely constructs of the human mind? And so on. But see, here's the problem too, though. One of the arguments that people make up who believe in the reality of mathematics is the idea, why does math work so well? Do you know how much math it takes? I remember I had a college roommate who was studying engineering. And I remember one day he was sitting here, he was working on, his engineering stuff, and he's doing all these numbers. And I still remember he looked up at me and he says, it takes an awful lot of math to fly a jet. I'm going to get on a jet plane on Monday. I got a 20-hour flight from Sydney to Atlanta. Am I looking forward to that? But I'm going to get on that flight, and they couldn't have built that jet if it wasn't for these numbers, these things. These numbers that they make up, and I'm sure they use negative numbers and all these numbers and things. So you're going to tell me they're not somehow real? And yet if you can't build bridges, the way we do today, or fly planes, or do physics, it's all numbers. And yet some argue that they don't even exist. How strange that something we don't even know if it exists, it's so good explaining, or at least describing. I don't think so much it explains as it describes what we do know that exists. I remember this quote from Bertrand Russell, one of the 20th century's greatest philosophers and mathematicians. He once said, quote, mathematics can, quote, be defined as a subject in which we never know what we are talking about, nor whether what we are saying is true. Close quote. Isn't that interesting? He says, we never really know what we're talking about or whether what we are saying is true. Now, they're talking with math here. Now, the news gets even a little worse. Let's go to good old geometry. Now, we all know Euclid and Euclidean geometry. The angles of a triangle equal 180 degrees, and the shortest distance between 2 points is a straight line. I mean, these are things that were basic. These are things that were taught. These are things that are foundational and fundamental. Geometry is about as fundamental, as basic as you could get because it's based on logic and reason, and even also on what you see. And for thousands of years or so, the entire intellectual world accepted the Greek doctrines of the axioms of Euclidean geometry. You know, these were truths about the physical world that were so clear and so self-evident that nobody in their right mind would doubt them. And because these axioms were true, all the theorems and everything that were logically deduced from them were true as well. So you were able to build, you got these absolute, irrefutable geometric axioms. And you work deductively. So if a deductive argument, if the premises are true, and then all your steps are going to be correct. So you could build absolute, indubitable truths based on these axioms of Euclidean geometry. I mean, what's the shortest distance between 2 points but a straight line? 2 point here. I mean, anybody could see that. So these were absolutely obvious, indubitable truths. And for a long, long time, this is what people were certain. These were absolute certainty for humans. Well, a funny thing happened in the 19th century. It was called non-Euclidean geometry, in which mathematics developed a logically consistent geometry in which parallel lines, you know, in Euclidean geometry, parallel lines don't meet, but in this geometry, parallel lines do meet. The angles of a triangle were either more or less than 180 degrees. And the shortest distance between 2 points was not a straight line. Okay? It was coherent and as logical as Euclidean geometry. But your axioms were different. Now, what happened was when they first came up with this stuff, people thought, well, that's fine and that's nice mind games and it's nice theoretical stuff to play with, but it doesn't have any meaning. It doesn't have any purpose. It doesn't apply to reality because that's just, you know, everybody knows parallel lines don't meet and the axiom and the number angles of a triangle. Well, it turned out that in reality, these non-Euclidean geometries better fit reality than did the geometry of Euclid. And that's because Albert Einstein's general relativity showed that space is curved and that everything is not this flat plane like what we think. In fact, you need Euclidean. Einstein had to go use Euclidean geometry in order to develop his theory of relativity. And the fact of the matter is the shortest distance between 2 points is not a straight line because space is curved. It's a geodesic. It's like a curve. Because imagine you're on a globe and you want to go to the surface of a globe to get to one point to the other, the closest distance. You go boop. It's not a straight line. It's a curve. Now the point is that this foundation of geometry, this Euclidean, in fact, when my son was taking geometry and studying Euclidean geometry, I kept on telling him, go tell the teacher that this is a bunch of bunk. That that it doesn't work in real life. My wife says, don't you tell that, you just be quiet and just do your work. Do your work, because in reality, the shortest distance between 2 points is not a straight line because of the curvature of space. But the point is the foundation of geometry, for all these centuries was eventually overturned. And these absolute certainties that they thought that they had for all these centuries was taken away. Now, it gets even worse. There was a mathematician named Gottlieb Frege. And Frege decided he was going to once and for all put all mathematics on a logical footing. I mean, after all, you'd think math, of anything, that should be logical. So he spent his life work trying to put math on a logical foundation. And he writes this massive work, and it's all that is his life work. And he decides he's going to send it to a young British aristocrat named Bertrand Russell, whom I've mentioned already. And Russell said he was quite impressed with Frege's work. But one of the most famous lines in history of thought, he says, yes, he says, but I have just one question for you. And with that one question, he destroyed the foundation of Frege's entire life work. And Frege admitted it, that Russell did it, that he destroyed the entire foundation. And it really comes down to basically what's known as the self-referential problem. And I'm just going to give you one quick, little mind game example. And this is really the foundation of the limits of really all knowledge. They say the barber of Seville, or Sevilla, I want to pronounce that right. The barber of Sevilla shaves everyone who doesn't shave himself. Okay? Simple enough. You're in the town of Sevilla, Spain, and you got a barber. And the barber shaves everyone who doesn't shave himself. Okay? So the question is, does the barber of Sevilla shave himself? Now, if you think about it, if he doesn't shave himself, then he must shave himself, because he shaves everyone who doesn't shave himself. But if he shaves himself, then he can't shave himself, because he doesn't shave anyone who shaves himself. Now, what you have here is not just some silly, mind-twisting word game. You have is a paradox that goes to the foundation and heart of all knowledge itself. In fact, by the middle of the 20th century, there was this work of the strange little Austrian fella named Kurt Gödel, G-O with the 2 dots, D-E-L. And he came up with what's called Gödel's incompleteness theorem. And he basically showed that there are inherent limits in what we can ever prove mathematically. In other words, you can't utterly prove absolutely the truth of mathematics. You know, he proved that with any given mathematical system, there'll always be certain statements that you cannot prove within the system. Now, you could go outside of the system and start and form new propositions, and then look in and prove those. But then how do you prove the propositions in your new system? You've got to somehow prove those things. Well, the only way you could prove those things is to go out of them, and you go on and on and on, infinitum. And ultimately, you never stop. So you never really can absolutely prove. There'll always be certain things unprovable and incomplete, even in something as foundational as mathematics. What this means is that knowledge of even simple mathematics remains incomplete, and then no one could ever be certain that the axioms of arithmetic will not contradict each other. In other words, even in something as rigid and solid and logical as math, some aspects can't be proven. I mean, to me, it's amazing that even hard, cold math, supposedly the foundation of all certainty, comes with certain intrinsic and inescapable contingencies. In other words, you could believe it, you could use it, you could apply it, but you can't prove it. There's this great book out, a fellow named Morris Klein. It's called what was it? I can't believe I forgot. Oh, I can't believe now the uncertainty of mathematics. I forgot. The name just slipped my mind now. I mean, it was almost like a Bible to me for a while. Morris Klein. Just remember that name. He's written a lot of books on mathematics. But listen to this quote. This is from Morris Klein on the work of Kurt Gödel. He says, the one distinguishing feature of mathematics that it might have claimed in this century, the absolute certainty of its results could no longer be claimed. And I don't know you, but I just find that astonishing. And here's a quote. Here's Bertrand Russell. He was the one who undid Gottlieb Frege. And then Russell spent decades trying to succeed where Frege failed. And listen to, I'm going to quote you here from Bertrand Russell. Listen to what he says. I wanted certainty in the kind of way in which people want religious faith. I thought that certainty is more likely to be found in mathematics than elsewhere. But I discovered that many mathematical demonstrations which my teachers expected me to accept were full of fallacies, and that if certainty were indeed discoverable in mathematics, it would be in a new field of mathematics, with more solid foundations than those that had hitherto been thought secure. But as the work proceeded, I was continually reminded of the fable about the elephant and the tortoise. Having constructed an elephant upon which the mathematical world could rest, I found the elephant tottering and proceeded to construct a tortoise to keep the elephant from falling. But the tortoise was no more secure than the elephant. And after some 20 years of arduous toil, I came to the conclusion that there was nothing more that I could do in the way of making mathematical knowledge indubitable. Close quote. I mean, I don't know about you, that is incredible to me. We're talking, he's saying I can't make math absolutely certain. We're talking about math how? Math now. Now, what is the point of all this? Where am I going on all this? Oh, excuse me. I've got 7 screws on a plate in my ankle, and it still hurts after all these years. The guy that broke my leg was at church the other day. We're all hockey players. And I said, Joe, I was thinking about you the other day, this morning. And he says, yeah. I said, yeah, my ankle was hurting. So my wife says, will you leave him alone about that already? But anyway, I don't know, is it the weather here or what? Maybe it's been killing me since I've been here. Anyway, the point is, and this is where I'm going with this. If something like mathematics, math now, cannot be proven, if to a certain degree it's got to be taken on faith, if it's something that you can believe, and we all believe in these numbers, we use these numbers, I mean, they work. They work. But if ultimately we can't prove them, then I'm going to get all worked up and bent out of shape that I can't prove, whatever that means, some of the basic tenets of my belief, or that I really can't even prove the existence of God, or I can't prove that there's a spiritual realm and a spiritual dimension to existence, that's something just inherent in all of us in humanity. I mean, that is because I can't prove them that I have to take them on faith. And yet, so what? So what? You have to basically take math on faith. How much more so than the things of God? And John Polkinghorne, he's a mathematical physicist and an ordained priest in the Church of England. And I like this quote. I'm not a big fan of him in other ways, but I think he hit the mark right here. He said, if we cannot even prove the consistency of arithmetic, it seems a bit much to hope that God's existence is easier to deal with. Close quote. And I found that very encouraging. I found that, I can't prove that parallel lines never meet, much less that God exists, or that Jesus died and that by faith in him all my sins are forgiven and I can stand fully pardoned before God. How do you prove these things? You could have evidence for them. You could have good reasons for believing them. But to absolutely prove them, I admit I can't. I can't really prove. I probably, if I sit there and think about it, I probably can't prove anything about my faith, about my Christian faith, depending how you want to prove it. Now, I can still have very, very good reasons for what I believe, but having good reasons is not the same as proving something. And I think I once said here, I think I said earlier in the week, I said, maybe I've read too much philosophy, but I'm not sure what it means to prove anything. I'm not sure what absolute proof really is, or even if it's even possible for contingent, subjective beings like us. So I said, I can't prove these things, but I have very good reasons to believe them. I might not be able to prove 2 + 2 = 4, but I've got good reasons to believe them. Sure, I can prove some things. I can't prove things that I can still be utterly certain of them. Certain enough of them to live my life and make my choices based on them. If I had to have absolute proof for anything, I don't know how I could get out of bed in the morning. I think of the story in the Bible. And the more, lately I've been doing a lot of reading on evidence for the resurrection of Jesus. Wow. That's a whole other sermon that I could get into sometime. The evidence for the resurrection of Jesus is powerful. In many ways, it's the only thing that makes sense given the facts. But how do you absolutely prove it? That's another issue. But I think of the story of doubting Thomas. Jesus had been resurrected. All of the disciples, all the others claimed they saw him. They all said they saw him. The women saw him. All the other ones, and he said he had all their testimony. And yet he would not believe. He would not believe. He says, unless I see it and feel it and touch it myself, I'm not going to believe. And then eventually Jesus appears to him. Then he says to Thomas, reach here your finger and behold my hands. Reach here your hand and thrust it into my side. And be not faithless but believing. And Thomas answered and said unto him, my Lord and my God. And Jesus said unto him, Thomas, because you have seen me, you believed. Blessed are they that have not seen and yet believed. I think it's pretty heavy that Jesus would say that, because most people he knew were not going to have the opportunity of Thomas, have the opportunity to put his hand and touch the scars of Jesus. Blessed are those who have not seen yet believed. Yes, there's a lot that I haven't seen. And there's a lot I don't understand. But I thank God for the gift of faith, for belief in what I don't fully understand and can't necessarily prove. Well, I know, I can't. I could say I can't prove it. But my point is, if it's something, though, like mathematics, and I guess this is the bottom line, if I can't prove that, but I've certainly got very good reasons for believing it, I would say that I would parallel it with my faith. I can't prove my faith, but I have very, very good reasons for believing it anyway.